Hello, folks. I'm gonna minimize this. Why not? All right, so this is 1.4, estimating square roots. We're gonna do a little bit of estimating, a little bit of calculator work, but basically you're gonna develop strategies for estimating square roots. A little bit of review. You know that the square root of a number is the number that is multiplied by itself to give the original number. So that's a lot of words to say the square root of 16 is the same as saying what times itself gives you 16. So it's the same as writing the square root of 4 times 4, and ultimately the square root of 16 is 4. So 4 times itself would give us 16. We can also relate this to a square. So I think written these formulas on a lot of your pages over the last few days. So it's good to know that L length squared equals area, and that the square root of area equals length. So in this square right here, we have the side length of 4 meters. So if we did 4 squared, we would get the area. So 4 times 4 is 16 meters squared. And if we took we used our formula and took the square root of this 16, we would get the side length, and we would get 4 because 4 times 4 equals 16. So that's how it's kind of shown visually. So the procedure, your calculator can square numbers and calculate square roots. This here, x squared, is the most common calculator button for a square number. That's how it looks on my favorite calculator, and I'll show you that in a second. And this radical sign with an x underneath is the most common calculator button for taking the square root. It's not how it's shown on my favorite calculator. It's just shown like this on my favorite. And you actually have to press the second function button. Whoops. I'll show you right here. So this is my favorite, as you know. Zoom in a little bit. So here, right here, if you can see where I'm pointing, is the x squared button. So you can press 8 and then the x squared button. That would be 8 squared. And you press enter or equals. If you want to get to the radical sign, it's right there. So it's just above this x squared. So you actually have to press the second function button and then press that button to access the symbol that's above it. So this calculator is, cool. You have all these buttons that you can press just on its own, and then you have all of the buttons that are also above it. You just need to press the second function button to access them. And on some calculators, you need to press this button after you put in the digit, and sometimes you have to press it before. So it's good just to explore your own calculator and figure out how yours works. So solve the following using your calculator. I have one on my computer, so I can use it right here. So 8 squared, on this one, you just press 8. You press the x squared button, and it does it for you, 64. Let's do next one, 11 squared, 121. Let's do the next one, 16 squared, 256. Now let's do the square root of 16 on this calculator. I think you have to put in the number and then press. This is our radical sign on this calculator. There we go. Now we're going to do 81. So let's do it together. 81, press the radical sign, it's going to be 9. And last one, 169. The radical button is going to be 13. Okay, so you can explore your own calculator. The iPhone one, it's not that great. You gotta move it to the side. I feel like not having the buttons actually pressed down can be a problem. I don't like the iPhone calculator, folks. So get a Texas Instrument one if you can. So what happens when you take the square root of 15? What answer does the calculator show? So let's have a little look. So let's try it. Let's try a non-square number, 15. We get 3.8729. Okay, 3.8729. Let's do some more. 8729, 8334. 6207. That's enough. Okay, we get it. So it's a really long decimal number. Now let's try multiplying 3.87 by 3.87. So just this part, these first three digits of the number. Do you get 15 as your answer? Why or why not? So let's test it out. Let's do 3.87 times 3.87, and we get 14.9769. So do you get 15 as your answer? No. Why or why not? What do you folks think? Why or why not? Well, here we go. A calculator gives a decimal approximation for the square root of a number, numbers that are not perfect squares. If we use many decimal places, we can get very close to the original number. What do you notice as you use more decimal places? So on this one, basically, we've kind of ignored all of this part of the answer. So that's why we aren't getting really close to 15, because we haven't kind of dealt with all of that information. So let's try this out. 3.9 times 3.9. So we can just do 3.9 squared, 15.21. Now let's get a little bit more specific. 3.87 squared, 14 point, oops, that was 9769, I think. Okay, now let's try 3.873 squared. Okay, 15.000129. This is just going to be the same, 15.000129. Just add in a 0. And then last one is even more specific, 3.87298 squared. Okay, we're a little bit below now. 14.999974080. Okay, so we're going to kind of be in between these two. So I think this one might be slightly more accurate, but still not quite there. So you can see, as you have more of these decimal places, you get more and more close to specifically 15. But the most precise way to show it, which is why we left our answers in this form last time, is just square root 15. So when taking the square root of a non-perfect square, the answer is a decimal approximation. Write the decimal approximation with 3 decimal places for the following. So let's do it. 23 square root. We're looking for 3 decimal places, so 4.796. The reason I said 6 instead of 5 is because we're rounding up this 8. This digit is 5 or above, so it's going to make this one go up. Let's do the next one. 463 square root, 21.517. Let's do the next one. 200 square root, 14.142. Okay, 105. 10.247. Let's do 39. 6.245. And last one, 87 square root, 9.327. Okay. Without using your calculator, how can you find the square root of a non-perfect square? Is there any way to know the first number? Okay, this is when we get into kind of what we're doing today, which is estimating. You don't need to write this down, square roots. Okay, so it's wonderful when we have our calculator, but if we don't, is there a way to kind of approximate what the first digit is going to be? So on the number line given, estimate where you would place the following square roots and what strategy to use. I'm going to give you folks a few little minutes to do this yourself. do your best and write down the strategy that you use to predict where they're going. So please don't use your calculator. Just do your best to predict what these things are actually worth. So remember, like the square root of 16 literally equals 4. So each of these corresponds to a number. So see about where you think they're going to be placed on this number line. Okay, so and then afterwards write down what strategy you use, and I'll ask you folks. So I'll pause it here. So what strategies do you use? Let's skip down to here, and I'll show you. So you can relate the value of a square root to the perfect squares. So you can draw a number line with the perfect squares above your number line. So this is our perfect squares number line, 0, 1, 4, 9, 16, 25. Remember, perfect squares is a number that can be a number, a whole number times itself is going to equal our perfect square. So this is 5 times 5, this is 4 times 4, this is 3 times 3, this is 2 times 2, this is 1 times 1. Each of these is going to correspond to a number. So this is saying that the square root of 25 is literally the same as 5. The square root of 16 is 4. The square root of 9 is 3. The square root of 4 is 2. So what we can do, find the number given on the perfect square number line, then drop downwards to the number line to get an estimate of the value of its square root. Remember that the scales are not the same, so you have to estimate the square root based on the number at either side. So let's find the value of the square root of 15. So the number 15 is between 9 and 16, but it's closer to 16. So this would be, say this is about half. It's going to be closer to 16. We're going to drop it down to our number line, and we're going to say, okay, so it's pretty close to 4. It's definitely above 3.5, and maybe a good estimate is 3.8. Okay. So the estimate of the square root of 15 is around 3.8. Because remember, the square root of 16 is 4 times 4. So we're guessing that the square root of 15 is going to be about 3.8 times 3.8. So to check, square 3.8. And let's see what we get. 3.8 squared, 14.44, not bad, which is close to 15. Okay, so maybe a better estimate would have been 3.85. We could try that, but ultimately we're pretty close, so not bad. It's a good estimate. Use the number line to estimate the values of the following square roots. So let's make our number line. 1, 2, 3, 4, 5, and let's make a corresponding perfect square line. So that would be 25, 16, 9, 4, and 1. So 6 is going to be between 4 and 9. Perfectly in between those two would be like kind of 7.5. So it's a little bit here maybe. So I'm going to guess 2.4. 3 would be about here. Let's drop down between those two. So we're past 1.5, maybe 1.7. Okay, let's look at 12. 12 is between 9 and 16. Pretty close to the middle, but a little bit before that because 12 is only 3 from 9, but it's 4 from 16. So let's guess right about there, maybe 3.3. And 20 is just before halfway. It's 4 from 16, but it's 5 from 25. So maybe I'm going to guess 4.4. So let's see how my guesses went. Where'd my calculator go? We can do 2.4 squared. Okay, 5.76, not bad, not bad. Maybe could have done better. Let's see, 1.7 squared, 2.8. Okay, I'm a little bit low on both of them, but not bad. Ultimately, not bad. 3.3 squared.